Hello. We have finished chapter 8, and today I will be demonstrating. I'll be demonstrating how to do homework 5, the empirical question in homework 5. The due date of homework 5 is May 11th, uh, Sunday. So, by the way, I have a few announcements. I set a deadline like far from now just because you may be busy and your computer may have some problems. So I allow you enough time to schedule when to do the work. Uh, but it doesn't mean you need to delay, you need to wait until the last day. So if you have a computer problem on your last day, obviously it is your problem. So you should have planned ahead, or like I know that the computer problem is kind of any kind of emergency is not expectable, but I know that I may be sick, or I may have similar problems, but you know that there may be unexpected problems. So expecting the unexpected, you need to work ahead. That's a natural response to to like what I do. So exploit the long due date, and like exploiting. I mean by exploiting, you have to do it ahead, so that if you have an emergency, still you can have plan B. That's one thing. And second thing, I still see that, so I do not grade the homework, but I ask the TA to grade now more detail, more carefully. For example, you have to make a table. I told you that you making a regression table is important, and I expect you to use a mathematical editor. You need to edit the equations on Word. And third, you have to submit a to file. So you have to be able to make stata to file. So these three things are what I ask you to do. So from now on, I will be more strict. I will ask the TA to be more strict in these three dimensions. You have to be, you have to, you have to make a more formal and good-looking answers on Word. You have to practice that. That's an important uh, objective of this course. Okay, back to homework 5, and we are going to consider a simple example. As usual, let me show you how you. I have done this many times. Here, you have to open, excuse me, to file editor. So to file editor, you get a new, a blank page, but you need to fill this blank page. The first thing you have to do is change, I will do this. Homework 5 by Byung Park. So, like if you write something after a sentence after star, then it is not recognized by stata. So you may just write down anything you think it's important. So today is April 16th. So writing this will be helpful. And some programmers prefer doing something like this, making it more beautiful. I don't think it's necessary, but there are some people who want to make a more splendid code. Then, you may do some art like this. It is not necessary, but it's also another useful function in coding. So I'm just showing you. And so always the first thing to do is to set the working directory. Your working directory may be different, so you have to do it by yourself. I put, no, I set the homework in this directory. So I will copy this command and put it on the do file. So change directory, and then second, I will open the data file. So use CPS 2015 DTA replace. So this is load data. So by the way, when you use star at the beginning of a line, that line is ignored. But if you wanna annotate in between a line, then you need to use slash star. Slash star starts on annotation, and then star slash will end the annotation. So the data will ignore this much part. So this is not recognized by Stata. So anyhow, we load the data. Then you see these variables: year, AHE, average hourly earnings, bachelor, female, age. So obvious, or like you know what they mean. I will type summarize to see what's going on. So the year is just one value. The standard deviation is 0, and average hourly wage is average. So the average of AHE is 21 something, minimum maximum, and bachelor's degree is either 0 1, female 0 or 1. So 52% of the observations have bachelor's degree, and 41% are female, and the average age is 29, but minimum is 25, maximum is 34. So this is how the data is composed of. So now the first thing we need to do is to run a simple regression. I will directly regress AHE on age, female, and bachelor, robust. So this is the first regression, and then you will get this regression results. Of course, you have to. I recommend you to use robust standard errors everywhere, like everywhere possible, and then you obtain these results. For example, the coefficient of age is 0.53127 something. So like if you get 1 year older, then your earnings is expected to increase by this much. And it's super significant, statistically significant, because the t statistic is very large, or like equivalently, the p-value is very small. And all the coefficients are very significant. Yeah, bachelor degree is the most significant variable. Like the t-stat is 37, excuse me. So super significant. Okay, this is this, and you just need to interpret the result as in the question. And what we are going to do is we are going to see what happens when you define a logged variable. I will define LHE as log of HAHE. So this is log of, so new variable is defined here. So as you can see, new variable is defined here, and then I will draw a histogram. So what we are going to, I'm showing you a new thing. We are going to make a histogram. Histogram is here. It's simple. Choose AHE. So let's think about the hourly earnings. This is the distribution of hourly earnings. What you can see here is the distribution is not symmetric. So the mode is here, the peak is here, and it has longer tail on the right hand side, but it drops quickly on the left hand side. Short tail on the left hand side. So even though I did not explain this in the lecture, this is another case where taking the logarithm is helpful. So now I will do the same thing for, so histogram histogram LAHE. So if you make a histogram for LAHE after taking log, this is the new histogram, because after taking the log, the distribution looks more symmetric, which is more desirable. So it looks more like much more similar to a normal distribution. So this is another reason why we are using the log variable. Taking the log makes the distribution more regular, more normal, and more kind of standard. Like what we and like the distribution is easier to handle and nice behaved. So and so then let's see. After taking the log, we are going to regress. Oops. Regress. Now I will estimate the regression, almost the same regression, with a different dependent variable. Now the only difference is to take the log is to use the logged variable in the dependent variable. And so compare these two results. First, just look at the age. The coefficient of age was 0.53 something, but now after taking the log, the coefficient of age becomes 0.02 something. It's not a problem. It is natural because log changes a lot of things. Or, okay, it will be also useful. If you compare, by using summarize command, if you compare two variables, average hourly earnings and the log of average hourly earnings, then the mean is different a lot. Mean differs a lot. Like 21 versus 2.9. So almost 10 times larger without log. And like everything is different. So of course the coefficients would be different, but the basic directions are the same. Age is positive, female is negative, bachelor is positive. Same thing, positive, negative, positive. And all are significant. And bachelor is the most significant. And same thing, all significant, and bachelor is the most significant. So even though the numbers change it because you are changing the unit, but the pattern, the trend does not go away. The same pattern is captured by those coefficients, like using different scales. Okay, and of course your interpretation should be now different, and especially careful when you interpret this because you took log on y. So remember how you can interpret the log y. Let's say it's log linear regression. So think about what we did in the lecture, in the slides, and interpret the results accordingly. And next, I am going to generate a squared variable, age square. Age 2 equals age times age. This is age squared, or you may use this. Doesn't matter. Exactly, this means square, but doesn't matter. Whatever you use should be the same thing. And if you execute this, then you see the new variable is generated. Age 2 is generated. Then now I will include age squared in the same regression. So in the same regression, I will include age 2 in addition. So run this. Then now we have an additional variable. Still, the dependent variable is log average hourly wage. So age squared is included, And now you have to interpret this. What's interesting here is its p-value is 1.6. The t-stat is minus 2.4 something. So at our typical significance level of 5%, it is significant. So quadratic function is significant. Quadratic term is significant, and the coefficient is negative, which means, so think about quadratic function with negative coefficient on the quadratic term. It is like inverse U-shaped. So it's inverse U-shaped, and so then think about this. As age increases, as you get older, your wage increases, your earnings increase, but at some point, after a certain point, your productivity may drop, or your like may drop, or the increment will the pace at which your wage increases will slow. So it is not linear, but it may go like this. So that's why the square term, the quadratic term is significant somehow. So, and also be careful when you interpret this. So combine now, you have to be careful about two things. First, considering the quadratic term, and second, considering the log. So also remember what we did in the slides, and it shouldn't be difficult. It's pretty intuitive example, so I believe you should be able to do this. And the next question. So I will number the questions. I will annotate on here. Say question 2A is here, and question 2B here, and question 2C here, and then it was question 2D here. So in this way, you make your codes more readable. And the last question considers an interaction term. The interaction term is defined as I will generate interaction, which is a multiplication of female and bachelor. So this is it. So simple. Just generate a new variable named interaction, whatever. The variable name is your choice. It does not matter, whatever you use. And it is defined as female times bachelor. And then using the same regression model, here now square term is included, but just add interaction. So the interaction term is included, and I will run these lines by clicking this. So choose this, and click execute. And then you get this result. As you see now, there is another variable. Interaction is defined here, and the interaction term is estimated here. Now the t-statistic is only 1.0, and p-value is 30%. So you should interpret this accordingly. So it's not that significant, but its coefficient, if you think about the coefficient, it is positive. So which is interesting, and also right, yeah, so it's positive, and all the other things have no big change. So just try to interpret what this means. So it shouldn't be a big difficulty. So okay, this is it now. You just need to make a regression table based on these 5 regressions, and then I explained how you make a table in the previous homework. I will post the 2 file. Okay, I'll see you later. Good luck.